Hello, this is our lecture number 5, and what we're going to be talking about today is, some additional methods of collecting data, ones that, uh, help psychologists to try to make conclusions about what our behavior is a product of. And this these additional techniques that we're going to talk about are ones that ultimately are going to help us to get at the truth. And again, one of the things that I want to re-emphasize from our previous lecture is that we're trying to um, build this pyramid of information that I talked about last time. Where there's really no such thing as ultimate absolute truth, but we can try to get there over a period of time by conducting well-controlled experiments. And this whole idea of getting at the truth in any discipline is so very important because we want to be able to make conclusions about what our behavior is a product of. So again, a number of different things that we'll be talking about as we go along. There are occasions where scientists, where psychologists can't conduct controlled experiments. And we're going to be highlighting some of those things as we go along. And I have a couple of examples of this that I think will help us to understand some of these other data gathering techniques that have become very important, not only in the field of psychology, but in other disciplines. So let's begin by starting with a very interesting hypothesis, a very interesting idea. And that is, let's say that you're interested in understanding visual development. And the hypothesis that you have is that normal visual development depends on certainly on your physical maturation. As you get older and older, um, you start out, when we take a look at the field of developmental psychology, and we'll be talking about the development of different behavioral systems. Certainly your physical maturation is very important, but how about visual experience? That is to say, what would happen, for example, if you had a blindfold on from the time that you were born until the time, let's say, you were 10 years of age? How would that impact you in terms of your visual development? Well, could you necessarily do a study like this in the case of human beings? For example, raise babies in total darkness. Well, obviously, that's something that's very unethical to do. You simply couldn't solicit the help of a family that maybe they're having a baby, and you confront them beforehand and say, hey, look, once your baby is born, I want to put a blindfold on your child as it develops, or I want them to be raised in a room which is totally dark. These are unethical things. These are things that certainly never, pieces of research that certainly never could be done. So we do have some alternatives, and certainly we could do some experiments with animals. There's been some very interesting research, for example, that's been done with cats, where where with young kittens, they've sewn their eyelids shut, and they've developed, let's say, for several months. And then what they do is they take those sutures out that are designed to keep their eyelids shut, so that now they can process information from the outside world, and they put them in various environments where they have to navigate through that environment. And what they find is that those kittens that have been deprived of this visual stimulation for a significant period of time, that they do understandably quite poorly in those situations where they have to depend upon visual cues in order to get from one part of a maze, let's say, to another part of a maze. They make a lot of errors. One of the things that we know from research that has been done like this is that the connections that ordinarily take place in various parts of the brain, namely in the back of the brain, in the striate cortex of the brain, that's where visual information goes. When we get to the whole area of vision, we'll be talking very specifically about that. That research has been incredibly important in terms of helping us to understand the development of visual processing. And indeed has helped us a lot in terms of, for example, individuals who have surgery on their eyes, some kind of corrective surgery on their eyes at some point in their life. There was a time when those individuals would be blindfolded for a very significant period of time. Well, we don't do that anymore. And the reason why we don't do it is because we realize that you're going to be causing problems in terms of visual development if you do this. So again, this is one method that we could use in order to take a look at visual development and the importance of visual experience in terms of that visual development. But we could also do some interesting studies, not experiments, but what I guess you would call retrospective studies, in which people have been born blind. We could take a look at when that surgery actually takes place during their development. Some individuals, that corrective surgery is done very early, whereas other individuals, it's delayed for a period of time. So they experience significant periods of their life in which they have no visual experience at all. So we could take a look at those individuals who had that surgery early versus those individuals who had that surgery at a later time. And we could explore, what happens in terms of their actual visual development. Well, this is not a controlled laboratory experiment. This is actually something that we call a correlation. In other words, we haven't been able to hold everything constant in this experiment like we would in a normal kind of an experiment where we have a independent variable and a dependent variable, and we totally control the experiences of an individual, totally control all the various variables that could potentially influence the work that we do. So this is, this is problematic. It doesn't really help us to get at these questions of cause and effect. Let me give you another example, which I hopefully will help you to understand this even better. Take a look at the following hypothesis. The hypothesis being the ability to hear spoken language is necessary for normal language development. In other words, if you were somehow in a situation where your hearing was compromised, maybe you had earmuffs that were placed on you during development. What would happen to your ability to acquire language? Would that language acquisition be normal? This is not something really that could be done in the case of obviously in the case of lower animals. They don't possess language in the same way in which humans do. But one thing that you could do is you could take a look at language development in subjects that were born with different degrees of deafness. And this is, what we call a correlational study. I mean, we've all been exposed to situations during our school years, for example, when we're in elementary school, middle school, high school, in which you have hearing tests. And there are individuals who have compromised hearing. Maybe it's only about 10%. In some cases, maybe it's more, 30%. In other cases, might be about 50% or 70%. And what we could do is we could gather information on a wide number of individuals who have experienced different degrees of deafness. And again, we can assess this by way of standardized tests for hearing. And then we could take a look at how well they have acquired language. And indeed, there have been correlational studies that have been done like this, in which they find, for example, that the ability really to acquire normal language development is severely compromised in individuals who experience 50 to 70% of hearing loss, as opposed to individuals where the hearing loss is much more marginal, maybe 5–10%. So again, this is not a laboratory-based experiment. This is not an experiment in which we can determine cause and effect. We don't have control over all the different sources of variation that would allow us to do a controlled laboratory experiment. So this is really just a method that allows us to take a look at possible relationships between two variables. In this case, it's the degree of deafness that a person experiences and what happens in terms of their language development. So again, this is an interesting way of also getting at these questions of what our behavior is a product of. Correlations are often misinterpreted. And here's a really good example of it. What would happen if we took a look at a person's college board scores, the SAT scores that many of you take in order to make application for college or university. And the Educational Testing Service, which is involved in the SAT and the GREs and so many other of these standardized kinds of tests that are used in order to explore where individuals are at in terms of, in this case, in terms of mathematical reasoning capabilities, writing capabilities, and so on. And if you take a look at information that has been acquired by the Educational Testing Service over a long period of time, you take a look at this. This shows roughly what happens when you test a lot of individuals in terms of SAT, and you can see that most individuals are scoring around here. Very few individuals are at the extremes where it's very low or it's very high. But one of the things that the Educational Testing Service has done is they've taken a look at those College Board scores and how individuals actually do in a four-year college. So when we take a look at grade point averages of individuals over the course of their college career, and then we go back and we take a look at their SAT scores, one of the things that we know is that SAT score is a pretty good predictor of grade point average and overall success in a four-year college setting. So individuals who tend to have a relatively high SAT score tend to do very well in terms of grade point average, tend to graduate on time. Individuals, on the other hand, who perform very poorly on the SAT tend to do very poorly in terms of grade point average, and indeed oftentimes don't make it through college. This is a correlation. We're not saying that SAT causes grade point averages. We're just saying that the two of these things tend to be related to one another. We do misinterpret correlations oftentimes as cause and effect, and I think that I have a very good example of that for you. What would happen if over a 2-week period of time in July we did the following experiment? We go down to the very popular beach area in New York, the Jones Beach area. and we take a look at the number of popsicles that are sold in the concession stands on Jones Beach. And then with the hospitals that are close, let's say within a 10-mile radius of Jones Beach, we measure how many people are admitted to those hospitals with heat stroke. And again, we do this every day for a 2-week period of time in July. And one of the things that we find is that when we take a look at this relationship on the days in which there are lots of popsicles that are sold and consumed at Jones Beach, there are lots of individuals that are admitted to surrounding hospitals with heat stroke. On days in which not many popsicles are consumed, bought and consumed on Jones Beach, the number of people admitted to those hospitals with heat stroke is very low. This is certainly very interesting, and maybe we would make, some might make the conclusion, well, consumption of popsicles causes heat stroke. That certainly is a laughable conclusion, and is not one that we would make. These two things are related to one another, but they're probably related to a lot of other factors, like the temperature, and like the humidity, and maybe the amount of actual sun that is present on that particular day. So it could be related to a lot of other things. Correlations, without question, are misinterpreted all the time, and we cannot really make the conclusion that these two variables, or that one causes the other. You can make predictions with a correlation, where, for example, we say, this day perhaps is 95 degrees, high humidity. You could probably a day in which a lot of popsicles are being consumed, you could predict probably fairly well that there's going to be many more people that are going to be admitted to hospitals with heat stroke. But again, the correlation has predictive value, but oftentimes, it's just completely erroneous to say that one thing causes another. Let me give you another example of this that I think will probably help you even more to understand what we mean by a correlation, which, by the way, is one of the first things that you'll study when you take a class in statistics. Correlations are simply the tendency of two things to occur together at the same time. We don't know whether or not they're causally related to one another. So let's take these 20 individuals that you see right here, and let's measure their height in inches. That's what this is here in this column. And let's measure their self-esteem by way of a standardized test for self-esteem. So person number one, their height is 68 inches, and their self-esteem score is 4.1. Person number two, 71 inches tall, self-esteem score of 4.6. Person number three has a height of 62 inches and a self-esteem score of 3.8. So again, we get these two things, height and self-esteem, for every individual, okay, in our experiment that we are conducting. Let's take a look at this in this figure that you see here. This shows this is simply a frequency chart. This shows height along the horizontal axis, 58 to 76 inches. This is relatively short. This is relatively tall. And you can see the number of individuals that score at these different levels, score at these different heights. So, for example, there are 3 individuals that are 62 inches tall. There are 3 individuals that are 64 inches tall. There are 6 individuals that are 68 inches tall, and so on. On the bottom portion of this slide, this shows self-esteem score. So again, we're taking a look at frequency. This is our self-esteem score from low to high. And what we see is that, again, here's 3 individuals that scored at 3.2. Here's a total of 5 individuals that scored at 3.8, just 1 individual at 4.6. Again, this is just a frequency distribution. But now let's do this. On this figure that you see right here, we're going to plot self-esteem and height for those 20 individuals. And take a look at these dots that you see here, right? And take a look when a person is relatively short, their self-esteem score is relatively low. Individuals however, who are taller tend to have higher self-esteem score. They're very high in terms of self-esteem. So these two things seem to be related to one another. Height and self-esteem appear to be related to one another, but would we necessarily say that they are causally related to one another? Take a look at what potentially can cause low self-esteem. Well, height, certainly, that might be a factor. I don't know whether or not it's a causative factor or not. Maybe the amount of bullying that an individual is exposed to. Maybe individuals that are short are exposed to more bullying than individuals who are tall. Maybe disapproving authority figures might be exerting some impact here. Uninvolved caregivers might be another very important factor. If your caregivers are relatively uninvolved, then maybe you develop low self-esteem. Academic challenges in which you don't have support, that too might be associated with low self-esteem. Some kind of trauma, maybe emotional trauma that you experience during early life. Maybe individuals that are exposed to more emotional trauma have lower self-esteem. The belief systems that you have, the society and media that you're exposed to. I mean, these are certainly all factors that also can contribute to low self-esteem. So again, I think that these are, what this is illustrating is that these things apparently are related to one another. But we don't know whether or not they're causally related to one another. That is, height and low self-esteem. So we have to be careful. I mean, this allows us to, again, to make predictions. Individuals that are relatively short probably have a tendency to experience low self-esteem more so than individuals that are tall. But can we necessarily say that one thing causes the other? Well, clearly we cannot. But again, correlations are used all the time in scientific research, but they don't allow us to establish causality, and that's a really very, very important point, because you're going to be reading about correlations all the time in the field of psychology. So, important take-home message here is you can make predictions from correlations, but you can't necessarily determine cause and effect. And this, I think, is a wonderful cartoon. This is a young boy that you see here with his mother. They're on an airplane. And the young boy says, wish they didn't turn on that seatbelt sign so much. Every time they do, it gets bumpy. Well, clearly we know that when you're on an airplane and that seatbelt sign comes on, it's because you're in the middle of a rough flight, but one doesn't cause the other. That seatbelt sign doesn't cause the bumpy ride. There are two things that are tending to occur together at the same time. And again, this young boy is wrongly making that causality kind of an interpretation, and we simply cannot do that. So again, correlations are important. We use them all the time. They're another way of collecting information in psychology, but we have to be very careful about the kinds of conclusions that we make. Let's pursue this a little bit more. by talking about what I call methodological problems, some of the most common ones. And certainly this thing that's called the self-fulfilling prophecy, which is all about expectations and how expectations can influence the outcome of psychological experimentation. We're going to talk about some really great studies in the field of psychology by Harvard psychologist Robert Rosenthal. One is on what's called the famous Bloomer study, and another is on what's called the Maze Bright, Maze Dull study. And what we're also going to do is we're going to talk a little bit about what's called the double-blind technique, which has become so important in all of science, certainly not just in psychology, but in all scientific endeavors. So let's look at Rosenthal's study. Here's Robert Rosenthal. And the study that we're going to talk about is one that was done a number of years ago by Rosenthal, and it's called the Bloomer study. In a fourth grade classroom, Robert Rosenthal met with the teacher of a fourth grade class prior to the start of the academic year. And there were 30 students in this class, in this fourth grade class that the teacher was going to be teaching that year. And what Rosenthal tells the teacher is that there are some students in this class, approximately 10 students, that are very bright, and the teacher should expect them to perform exceptionally well. And he writes down the names of the students on a piece of paper, and he hands this to the teacher and tells the teacher that this is, excuse me, that this is that these individuals, again, based upon all of the records that he's taken a look at, that these are students that the teacher can really expect to outperform everybody else. Well, there's some important deception that's going on here that we'll talk about in just a few minutes. But what Rosenthal does is he tracks these students over the course of the entire semester. And he goes into the classroom very frequently, takes a look at the exchanges that take place between the students, between all the students and the teacher. And what he finds in the first few months of class is that really those students that have been identified as being these really smart, he calls them bloomers, they perform just like the other students in the class. But then as time goes on, during the third month, fourth month, fifth month, sixth month of this fourth grade academic year, the students that had been identified as the bloomers start doing incredibly well and much, much better than the other students in the class, to a point where by the end of the year, the academic year, those students that were labeled as bloomers are doing much, much better by way of taking a look at standardized kinds of tests. Well, there's important deception here. And the deception is that the students that were labeled as the bloomers indeed are no different at all in terms of their academic background coming into the fourth grade year, no different from any of the other students in the class. So again, start of the year, fourth grade children are this list of students that are bloomers given to the teacher. The deception is the bloomers were no different from other students in the class. The bloomers outperform the other students in the class, and the question, of course, is why. Well, when Rosenthal takes a look in the classroom in terms of what is going on, he finds that over the course of the academic year, the teachers are favoring those kids that have been identified as bloomers, giving them more attention, calling on them much more in class, and indeed this attention, this greater attention, that's really responsible for what he's found. Really responsible for the elevated performance of those individuals. Indeed, this is an incredibly important study. One that has been duplicated, replicated, a number of different times. And, one of the things certainly that we know is that when you're given a lot of attention, when you're given a lot of additional help, when you're given a lot of additional stimulation, it can be reflected in these differences that take place in terms of performance. So again, this is, self-fulfilling prophecy. And indeed, this study is one that is often discussed, and is one that is so important in terms of how we go about educating young people in the classroom. And Rosenthal conducts another study which is very similar, but except this is one in which he works with animals, and it's called the Maze-Bright, Maze-Dull study. Rosenthal calls into his laboratory some students that are interested in working with him, approximately 20 students at the start of the school year, and he assigns each one of the students to a rat that's in his laboratory. And some of those rats are rats that are very, very bright because they can go through a maze and not make very many errors at all. And other rats are rats that he calls maze dull, in which there's these are rats, he says, that are can be expected to perform at a very low level, take a long time to go through the maze, and make a lot of errors. So each group of 10 students, each one of them is assigned one of these Maze-Bright rats, and another 10 students are assigned, each one of them assigned a Maze-Dull rat. They're supposed to take care of them, come into the lab every day, and place them in the maze, and count the number of errors that they make in the maze, and how long it takes them to get to the goal area where there's some food for the animal. And again, the students do this every day over a 2-week period of time. Deception involved here, just like in the previous study we talked about. In reality, those rats were not different from each other at all. Okay, their performance in the maze was absolutely identical to one another at the start of the experiment. This is simply deceptive information that is being given to the students. What happens, indeed, is very interesting. The Maze-Bright rats, over the first 3 or 4 days, are performing at a level similar to that of the Maze-Dull rats, but then after about 4, 5, 6, 7 days, those Maze-Bright rats start getting better and better and better, and the Maze-Dull rats, their performance actually, starts to go down. Every single day, Rosenthal watches the students in the laboratory, watches how they interact with the rats. Again, the students are very dutiful. They come in every day at the same time and take their rat that they've been assigned, take it out of the cage and places it into the maze, and then they record the errors and the amount of time that the rat takes in order to traverse through the maze, and they record that information and they give it to Rosenthal, every single day. And again, by the end of the experiment, these Maze-Bright rats are just performing in a spectacular fashion, and the Maze-Dull rats, their performance is very poor. The observations that Rosenthal makes of the interactions between the students and the rats that they've been assigned are very interesting. The students that were assigned the Maze-Bright rats gave them a lot more attention, handled them a lot more every single day when they were in the laboratory, oftentimes bringing, food, like things like Oreo cookies, for example, brought them to the rats. Rats have a sweet tooth just like human beings do, and the rats absolutely love those Oreo cookies. The students that were assigned the maize doll animals didn't do this. They didn't handle the rats anywhere near as much. Certainly didn't bring things to them that they might enjoy eating. And one of the things that we know about handling, at least in lower animals, but also in the case of human beings, is that it can have very definite physiological effects. It can change the way, for example, the biochemistry of the brain. It can change the structure of the brain. We know this from handling studies that have been done, for example, not only with animals, but also with human beings. The swaddling of a baby, for example, the handling of a baby can have very, very definite effects upon the development, the physiological and behavioral development of a young child. So again, this is another really great example of this thing that we call self-fulfilling prophecy and expectation, and how these things oftentimes come true. Labels that we give to someone or to something, and indeed, these studies are ones that are incredibly important for how we organize our educational system today. There was a time years ago when children, for example, were placed in different tracks based upon their presumed intelligence on the basis of the standardized intelligence tests, for example. And in my day, for example, in high schools, you were either in tracking in terms of a general kind of academic curriculum or a college curriculum or a business curriculum. Those were the three different tracks that we had, and that can be absolutely devastating. We don't believe in that anymore. And the reason that we don't believe in it is because of all of these expectation effects and self-fulfilling prophecy. So again, these are very important studies that help us really to be aware of potentially what can happen in an experiment where maybe the preconceived notions, for example, of an experimenter are somehow influencing unknowingly the outcome of a particular study. So how do we prevent this from happening? Well, certainly one important technique is something that we call the double-blind study. And in the double-blind study, neither the experimenter nor the subject know who is in the experimental group and who is in the control group. And so how would this be reflected in an actual experiment? If you take a look, for example, at a very simple study, which let's say a psychologist is interested in the effects of a drug, let's say a new minor tranquilizer that has been developed. They want to understand whether or not that's going to be impairing memory processing. What that experimenter would do is they would contact a third party. And in this case, it would be, let's say this is being done in a large hospital setting. And they would contact the pharmacist that's within that hospital setting to have these pills that are the tranquilizer, and put some of the pills in in envelopes that have the pill has a tranquilizer in it, and they take other pills that don't have the tranquilizer, something that we call a placebo, and put those in envelopes, separate envelopes. And though the envelopes would be the same, there simply would be a mark on the outside of the envelope saying envelope number 1 and envelope number 2, envelope number 3. And the pharmacist would keep track of what was actually in each envelope. So, for example, envelope that we see here, envelope number 1 is given to subject number 1. That envelope has the drug in it. Envelope number 2 given the subject number 2 has the placebo in it. Envelope number 3 also has a placebo in it. Envelope number 4, given the subject number 4, has the drug in it, and so on. So this is the list that this third party has, in this case, the pharmacist. And the pharmacist is going to hang on to that list, and he's going to give that series of envelopes to the experimenter. The experimenter, again, is going to be giving these envelopes to the subjects, and he's going to be taking a look at what happens in terms of, some simple memory kinds of experiments. Let's say an hour after the individual consumes the pill, they're given this standardized kind of a test in order to explore memory processing. And again, the experimenter doesn't know what's in the envelope, knows that it could be a tranquilizer, or it could be a placebo that looks identical to that of the tranquilizer, but doesn't have the tranquilizer, doesn't have the drug in it. But the end of the experiment, now, again, he's recorded which person gets which envelope, but he doesn't know what's in the envelope, and the subject doesn't know what's in the envelope. At the end of the experiment, he's going to get this list from the pharmacist as to what is in each envelope, and then he can go back and he can take a look at which subject got the tranquilizer and which subject got the placebo. And indeed can, after doing this, can certainly explore what happens in terms of the outcome of the experiment. So again, in a double-blind study, which is used all the time in the field of psychology, the experimenter doesn't know who's in the experimental group, and the subjects don't know who's in the experimental group, who's in the control group. Okay, simply don't know. It's not until the end of the experiment, after it's been completed, that the experimenter can find out by getting that list from the third party. So the double-blind technique is something that we use all the time to eliminate these expectation effects, to eliminate self-fulfilling prophecy. Here's another interesting, what I call problem of measurement, and it's what I call thinking that you're manipulating a variable when in fact you really aren't. And I go back to some experiments, some old experiments that were done a number of years ago on a phenomenon that was called learn while you sleep. There was a company out on the West Coast here in the United States that was marketing these audio tapes that you could put into an audio tape machine, a tape recorder, and you could play those audio tapes at night. You could program them to come on at a certain time, let's say maybe an hour after you've gone to sleep, or a half hour after you've gone to bed. And there were audio tapes, for example, to learn mathematics. There were audio tapes to learn the French language. There were audio tapes to learn physics. There were audio tapes to learn chemistry. And then, presumably after these audio tapes play at night while you're sleeping, you wake up in the morning and, you're brilliant because you've listened. Let's say you want to learn French language. And you put one of these audio tapes in, when you wake up in the morning, you know how to use the French language, and proper grammar and so on. Well, these audio tapes were being very aggressively marketed, and a number of psychologists and other scientists on the East Coast became very interested in this phenomenon of learn while you sleep. And they wanted to bring this into a laboratory setting and really test in a very rigorous manner whether or not this was a phenomenon that was actually truly happening. So what they did was this. They started to do some experiments in which individuals would come into a sleep laboratory and they would measure very precisely brainwave activity. while these individuals were sleeping. And one of the things that we're going to learn about brainwave activity while you sleep is that there's some very definite changes that occur when you are actually asleep, in terms of how you transition into certain types of brainwave patterns. And what these researchers were finding was that when they actually played these audio tapes while individuals were truly asleep by way of their brainwave activity, and then they were tested later on in the morning when they woke up, they didn't remember a thing about what was on those audio tapes. So the scientists now in the East Coast call this company that had been making a tremendous amount of money on these learn while you sleep audio tapes, and they asked a very simple question of this company. They said, how do you go about defining when a person is actually asleep in the studies that you have performed? And indeed, what they report, what this company reports is they say, well, it's when you have your eyes closed. That's how we define sleep. Well, you know as well as I do that you can have your eyes closed and you can learn really, really well. So it's not learn while you sleep. It's really learn while you are awake. And again, this is obviously fraudulent. When you use a rigorous definition of sleep, such as what the scientists on the East Coast were doing, then you come up with very, very different kinds of conclusions. Okay, so this is a problem in science, is that we have to precisely define what it is that we are measuring. In the case of psychology, we have to precisely define what sleep is. And we can define it in a very rigorous manner in terms of brainwave activity. And you come up with very, very different conclusions based upon the rigor with which you define what it is that you are measuring, define what it is that you are manipulating. So this is something that is so important in psychology, is to define precisely, based upon the latest science, what it is that you are studying. And in this case, the variable is sleep and how we go about defining sleep. So again, these problems of measurement come up all the time, and they're a very important part of the field of psychology. So here are some guidelines that I think that are important ones for you to reflect upon. Guidelines in terms of getting at the truth in psychology. And certainly one of the most important one is that when you evaluate an experiment, you're going to be reading about a lot of experiments. You need to ask about the subjects. How many of them are there in the study? How exactly were they selected? Were they randomly selected? There is no more critical piece of information when you're reading about any kind of an experiment in any field. Ask about the subjects. Are there a lot of subjects? Are there only a few subjects? How were they selected? Were they randomly selected? Do they represent the universe of all possible individuals? I mean, this is crucial information. Another very important guideline. You have to avoid the assumption that two things are really cause and effect related. Correlation is not necessarily causation. We talked about correlation. Okay, so you have to keep this in mind as well. Seeing isn't believing. If there's information that you're not given about an experiment, about the methods used, about the subjects, for example, if there's information that is being kept away from you, then your ability to really determine whether or not that experimentation is good or bad experimentation is really severely limited. All right. So again, Seeing isn't believing. And again, if there are things that you're not told, things that are kept away from you, then your ability to really say that that research is good research is severely limited. Question any data that are collected in which we use the latest methods, the rigorous methods of science, meaning the scientific method, developing a hypothesis, independent variables, dependent variables, experimental groups, um, control groups, randomly selected subjects, and so on, right? Very critical. Okay. Any conclusion about human behavior is really only as good as the data that we have collected. Okay. So, science proceeds in this stepwise manner. Sometimes it's slow, but we're trying to get at the truth, and getting at the truth really requires us to collect data in a very deliberate fashion. Um, Keep in mind the self-fulfilling prophecy, experimental bias. That can change the reality of a situation, the reality of the kinds of results that you obtain so easily, and sometimes it happens in such a subtle manner in psychological experimentation. So you really have to be very, very careful in interpreting studies. Reading the methods becomes so crucial to understanding whether or not this is good research or this is poor research. And indeed, that's one of the goals that we have in a class in psychology, survey class in psychology, is to get you to be good consumers of psychological information. Restrain your enthusiasm for scientific breakthroughs, replication, duplication. Remember, we talked about that building of the pyramid, right? That pyramid of information. It takes a long time. It can be very difficult because it takes so long. So again, your desire to want to apply something very quickly to your own life becomes severely restricted if you jump to conclusions after a single study that hasn't been duplicated by someone. Beware, there are people in our world, psychologists, sometimes certainly other scientists who claim absolute truth. And claim simple solutions. And again, human behavior is incredibly complex, and making these kinds of dogmatic, absolute kinds of truth conclusions about something that is so complex as human behavior is something that we have to guard ourselves against. So again, this is an important topic. And methodology in psychology is something that is at the core of our discipline. Being able to make these good conclusions about what our behavior is a product of. Scientific conclusions are always tentative. Okay, they're never absolute. They can change, with new experimentation and new data that comes along. And again, this is something that is a part of the scientific process. So hopefully you have a better appreciation for this at this point in time.